Okay, here is the second page of the extra credit worksheet that I'm going to go over with you guys, and it gets into a little bit more of the series, which will be good for us to go over today. And I want to show you one little thing, and we'll be discussing this in class as well, but this is the little handout that I'm going to give you guys today so you'll know the formulas. Let me kind of just zoom in on that. And remember from yesterday's video that the top row is going to be your arithmetic, the bottom row will be your geometric, and these are both explicit. These are both your series or your summation formulas for finite, and then this is the extra geometric because you can actually sum infinite as long as they are decaying. So this would be R must be less than 1. It's the absolute value of R. So you're going to look at that. So we'll be using those today. So I'll kind of point that out. Okay, so write an explicit rule for each of the following sequences. So a sub 4 is 15 and a sub 9 is 30. So remember in class I taught you this is basically just the slope formula. And I'm going to take 30 minus 15 and divide that by 9 minus 4. And of course that'll be 15 over 5 or 3. Okay, so the other part to this is I need the first value, and if I'm subtracting 3 every time, I could think of it like this: 1, 2, 3, 4. The fourth term is 15, and I could kind of just work backwards. So subtract 3, and it's going to be 6. So the first term is 6. You can kind of double check yourself there, or you could just use the formula and go ahead and solve for the first value. I think that's probably easier for most students, is just to think about it logically like that. So the explicit rule is going to be this formula right here. So I need my first value, I need my common difference, and I have both of those. So a sub n is going to be equal to a sub 1, which is 6, we said, plus my common difference of 3, and then n minus 1. So that's how you would do that one. Okay. The next one, a sub 12 is 6, and a sub 15 is negative 4. So you can see this is kind of going down in value, so it's going to be a subtraction, or the common difference will be negative, if you want to think of it like that. So again, my slope formula, which is really just my common difference, is going to be negative 4 minus 6, and then I'm going to have 16 minus 12. So this will be a negative 10, and then this will be a 4. So it's going to be a negative, we'll simplify that down to a negative 5/2, like that. So that's my common difference. Now this time I think I'm going to use the formula because the fraction presents kind of a different scenario. It might be hard to work backwards like we did on this one. And we're at the 12th term, so we'd have to work backwards quite a bit. So what I'm going to do is I'm going to use the formula, the explicit formula here. This one, I'm going to solve for a sub 1. And what I'm going to plug in is an n, so the term position, and the term value. So I will just start with this first one right here. Remember, this is really just saying the 12th term is the value 6. So it's like an XY ordered pair, if you want to think of it like that. Okay, so I'm going to basically say that the value is 6. And I'm looking for the first term. I know my common difference is a negative 5/2. I really should have written subtract there, so I'll just change that. And then that is going to be n minus 1, and my n here is 12. So it's the 12th position. And this right here, deciding which goes where, is probably one of the harder things that we do. Okay, so what I'm going to do is simplify this a little bit, and I get 6 is equal to a sub 1, and then 12 minus 1 is 11, so it's going to be 5/2 times 11, and that's just going to be negative 55/2 when I multiply this out. So a sub 1 minus 55/2 is equal to 6. So what I'm going to do is add the 55/2 to the net value of 6. And we're going to get a decimal on this one. Well, we would get a fraction, of course. So I could just add 55 halves to 12 over 2. So 55 plus 12, of course, is going to be 67 halves. So a sub 1 is going to be 67 halves. So then I'd write out the formula. And what I want to do is basically pick up the values I need. So I need a sub 1, my first value, and then I need my common difference right here. So I'm going to put that back into the formula. And again, here's the formula. So a sub n is going to be equal to my first term, and then it's going to be minus 5 halves because that was my common difference. So let's write that out. So a sub 1, which is 67 halves, so I'm going to say a sub n is equal to 67 halves, and then it'll be minus 5 halves, and then n minus 1. This is your explicit formula, and that one was a little bit hard because of the fractions, but you still follow the exact same process. You want to first find your slope, and then the second thing is you use that slope, and then you pick one of the two, basically the 2 points they've given you. And you use the term position and the term value, and you solve for your first term. So that's how we're going to do those. Okay, so find the sum of each of the following series. So first we need to determine, is this arithmetic or is it geometric? And it looks like it's going to be arithmetic because 3 plus 6 is 9 plus 6 is 15. So I'm going to say this is arithmetic, and D is going to be 6. So that's important. Now, that tells us we're going to use this formula right here. And I need to know what term I'm summing through. I do know the first term and I do know the nth term, but I don't know where is 183 in the whole pattern. So I'm going to have to use my other formula, the explicit formula, to find the n. So I'm going to be solving for n in this one. So what I'm going to do is I'm going to say a sub n is equal to my first term of 3 plus my common difference of 6, and then I'm going to say n minus 1. So that's the explicit formula. So I just wanted to write that out for you. And then I can basically just solve for n right here because I know that a sub n is 183. So I'm just going to replace this with 183. So then what I'm going to do is subtract 3 and divide by 6. So it's just going to be 180 divided by 6, and then I get 30, and then so I'm going to have 30 is equal to n minus 1, so n is going to be 31. This is important because I need that for my formula. So then going back, I'm going to fill everything into this formula right here. So s sub 30, because I'm summing through the 30th term, is going to be equal to 30. And then I'm going to have the first term of 3 plus 183. So I have the first and the last terms, and then divide that by 2. So you're just literally plugging all that into your calculator. So you have 186 divided by 2, and then you're going to multiply that by 30. So the summation there is 2790. And that's your answer for that problem. Okay, now the next one. First of all, we need to decide, is this arithmetic or geometric? It looks like I'm going to be adding 9 every time, so it's going to be arithmetic. So arithmetic, and the common difference is 9. So again, I need to figure out where this is in the whole pattern. So I'm going to say 403 is equal to my first term of negative 2 plus my common difference of 9, and then n minus 1. Okay, now what I would suggest, since you've already seen number 20, I would say pause the video and you try to solve this from here and come back in just a second and check your work. Okay, so I got an n of 46, and again I'm just using the formula, this formula right here, and I know n is 46, so I use it there and there. And it doesn't really impact anything here. And then I know the first and the last term. So plug everything in. So s of 46 is going to be equal to 46 times the first term is negative 2 plus 403 divided by 2. So do that in your calculator. And I got 9223. So make sure that is what you got. And you can pause, rewind, go back and kind of go through it and make sure you're understanding it. Find the indicated sum for each geometric series. So now we're told it's geometric. Up here we were not told, so we had to double check. Here we're told it's geometric, so I don't even need to check these. So what I need to do is basically just divide 42 by 14 and see what I get. So I get a 3. So that means R is a 3. Okay. Now we are now using either one of these two formulas. Okay. And we're supposed to find the sum. And if you remember from our lesson about geometric finite versus infinite series, I can't actually sum this one because it's increasing. R is bigger than 1. The absolute value of R is bigger than 1, so I cannot actually sum this one. So just say no answer here because you can't sum it because it's increasing, getting larger and larger. Okay, let's try the next one. Okay, so this one is saying sum through the 8th value. You know what? I just realized there's S sub 7 there, so oops on that. That would be if basically it just said continue in this pattern, you would not be able to sum that. But because it says through the 7th term, we can actually use this formula right there. So let's go back to that. Sorry, I didn't recognize that. So S sub 7 is going to be equal to G sub 1, which is 14. I have 1 minus my R, which was 3, raised to the n, which is 7, and all that divided by 1 minus our R, which is going to be 3. Okay, so this is just plugging it into the calculator. And remember I said you probably want to do all of this and then just go ahead and divide by this value and then multiply by 14. So kind of do it step by step. I would suggest getting into the habit of doing this in parentheses though, because it will help you when you have a negative. So divide that by -2 and then multiply by 14, and I got 15,302. So this is 15,302. Okay, same thing for this one down here, but I do need my common ratio. So if I do -4 over 1, I can see that R is a -4, and it follows that pattern. If you're dividing this by this, you get a -4, this by this, you get a -4. So I'm going to sum through the 8th term, and my first term is a 1, and then it's going to be 1 minus, and then it's a -4 raised to the nth, which here is an 8. And then all of that will be over 1 minus a -4. So that's 1 plus 4, or just the number 5, obviously. And you're going to plug all that in your calculator. So 1 minus, and again, use your parentheses just like we wrote it out there. Okay, and I got -13,107. Now you may be wondering, well, how did we get a negative? Well, it's because some of these values will be negative, and just through the 8th term, we happen to have more negatives than positives there. All right. So moving on, decide whether the infinite geometric series has a finite sum. If so, find the sum. So basically, we're trying to figure out if we can use this formula right here, but remember the absolute value of R must be less than 1. So when I look at this one, yes, I can, because R is 1/2, so it's obviously less than 1. So if I'm summing through the infinite, basically, outcome of this sequence, it's going on and on forever, but it's okay because it's approaching 0, like I showed you graphically yesterday. So I need to know what my inputs are. Basically, I just need my first value, which is a -2. So it's going to be S through infinity is going to be a -2 divided by 1 minus 1/2. So 1 minus 1/2 is just 1/2, obviously. So it's going to give you just a -4, of course. Okay, and you can do it in the calculator, or you can do -2 multiplied by the reciprocal here, and you get a -4. Okay, so let's look at the next one. It appears that this is decaying, so I think we could probably do this. So 2 over 8 is 1/4, so R is 1/4. So we can sum this. So we're going to sum through the infinite sequence here, and I'm going to say my first value is an 8 and divide that by 1 minus 1/4. Okay, so that is going to be 8 divided by 3/4. So you get 10.66, so it's really 10 2/3. Well, it's 10.67, rounding it off. And there you go. Okay, this one appears to also be decaying. So 0.5 over 5 is just going to be 1/10. So 0.5 over 5 is going to simplify down to, you could do 0.1 if you want to. Okay, that's fine. So I can sum this one, summing through the infinite series here. My first value is 5, and it's 1 minus 0.1. So 5 divided by 0.9 is going to give me 5.55 repeated. We'll just do 5.56. That will be your summation. Okay, now, so let's do a couple of the word problems here and see what we get. So in the first year on the job, Matthew earned a salary of $20,000. He received a 5% raise each year. What were his total earnings over the first 10 years he worked here? So first I need to decide how this is growing. Is it a constant rate, or is it going to be some sort of exponential growth? And because he's receiving a 5% raise, he's increasing each year by 5%. So this is GM. Okay, so I had a brief interruption there, but I just want to show you this problem here. So let's continue on with this. So I have, in his first year on the job, Matthew earned a salary of $20,000. He received a 5% raise each year. What were his total earnings over the first 10 years he worked there? So this is geometric, and remember that that fits with exponential. So what I need to remember is that this 5% is really going to be 1 plus 0.05, because you want the base value, or the rate of growth, to basically keep 100% and then grow it at 5% each year. So it kind of fits with this model right here. So I'm going to use 1.05 as my R, like that. And then, so just using the formula, I'm summing through the 10th year. So I'm going to use this formula here for finite through the 10th year. My first year is 20,000, and then of course it's 1 minus my R value, 1.05 to the 10th, and then divide by 1 minus 1.05. So go ahead, I would suggest do this in the calculator, like in the numerator. Do the numerator first. Okay, and I'll kind of just show you if you can see what I'm doing in my calculator there. Kind of hard to see. Okay, so you go and get that value, and then you'll divide that by 1 minus 1.05. So you just kind of continue on and divide that by, and in parentheses do 1 minus 1.05, get that value, and then you're going to multiply by 20,000. So I'm doing, oh, y'all can't really see what I'm doing there. There, maybe you can see that. So that kind of shows you step by step what I'm doing in the calculator, if that's helpful. Okay. So I'm going to get 251,557.85. So the answer to this is going to be 251,557.87. So that is the answer. Okay. Now, moving on. So there are 25 rows in a small theater and 52 rows in the last row. Each row from the front of the theater to the back has one less seat than the one behind it. How many total seats are in the entire theater? So we need to kind of think through what this is. First of all, it's arithmetic because we are just every time subtracting one, okay? So there are 25 rows in a small theater, and there's 52 seats in the last row. So let's just kind of draw this out. And it says each row from the front of the theater to the back has one less than the one behind it. So it's growing by one as you go back. Every time it gets one bigger. Okay? So that's kind of the scenario what we're talking about here. So each row we're going to add one. Each row from the front of the theater to the back has one less than the one behind it. So this one's going to have one less than this one has one less than that one. And there's 25 rows, and there's 52 in the last row. So let's kind of think through what we're dealing with here. We know our common difference working from front to back. Well, we could actually work either way. It doesn't really matter. Either way, we have to solve for something. So let's just go ahead and say the common difference is going to be 1 because we're going to add as we go to the back. Okay. And we know that A sub 25 is equal to 52 because we know the 25th row has 52 seats. So 25 rows in a small theater with 52 seats in the last row. So the back row has 52. So what we now need is A sub 1. We've got to find A sub 1. So we're just going to use our explicit formula, and we're going to say 52 is equal to A sub 1 plus the common difference of 1, and I'm going to do n of 25 minus 1. So basically, I'm going to, this is 24 of course, I'm just going to subtract 24. So 52 minus 24. So 28 is your first value. And since we know that, we're ready to use this formula right here. So I know I'm summing through the last row, which we know is the 25th row. So I'm summing through the 25th row. So n is 25. My first value is 28. My last value is 52. And then I have to divide by the number 2. So that is how you would do that one. And I got 1,000 seats. And you do want to put this with units because it's seats. Okay, now we have one ball balancing problem which we do need to go through. And remember that you have to kind of modify the answer at the end. We went over that in class yesterday, but I'll review it again here. So a ball dropped from a height of 7 feet. The ball rebounds at 5/6 of its previous bounce on each bounce. So this is basically just saying this is your R of 5/6. So find the total distance the ball travels after 6 bounces. So we basically want to sum through the 6th term. And then we're also going to find the total distance the ball will travel before it comes to rest. So we're going to sum through the infinite series there. Okay, so we pretty much have everything we need. So we just need to know our first value. Remember, we're going to use this formula for summing through the 6th term. So I'm going to say G sub 1, which is 7. And then I have 1 minus my R of 5/6 to the, now we want to sum through the 6th value, so do 6 here. And then we have 1 minus 5/6 here. So plug that into your calculator. And I did the numerator first, then I'll divide that by the denominator, and then that value I'll multiply by 7, and I got 27.93. But that 27.93 has to be doubled but then I have to subtract out the initial drop, okay? Because remember, the first time it goes down, but then it goes back up, back down, back up, back down, all the way through the 6. So the problem is, when I double it, I'm adding this, but I'm not really actually, the ball doesn't really travel that distance. So just do that, 27.93 times 2 minus 7, and we get 48.87. So it's approximately 48.87, and that's going to be feet. Okay, and the next one is a little bit easier even, because you're summing because you can, because r is less than 1. So I'm using this formula here. G sub 1 is going to be 7, and then 1 minus 5/6. So go ahead and do that in your calculator. And I got 42, but remember you have to double that and you have to subtract the 7. So 42 doubled and subtract the 7, and you get 77. So 77 feet is the total distance there. And there you go. So that's the end of the worksheet. So hopefully that helped you with all the what we're doing on the quiz. And if you watch both of these videos, you'll definitely get some extra credit for that.